Okay, today we're going to do our first video for our third unit, and we're really going to dive into scientific notation. We're going to use what you learned today in class over the powers of 10 to learn how to not only write a number in scientific notation, but to also take a number that's written in scientific notation and be able to translate it to decimal form. Let's go ahead and get started. The format for scientific notation, basically you're going to see some number, then a decimal, then the remaining digits of that number, and you're going to go times 10 to the something power. The format will always look like this. Um, the only exception is you might have a 0 here, which would just leave you with 4 times 10 to the something power. But that first number, this number right here, that first number must be greater than 1 um, and less than 10. Okay, so if you look at this first number, you can't have, it's got to be bigger than 1 and less than 10. Okay, so you won't ever see something like 12 inside here because that would make this entire number greater than 10. It'll always be, like I said, greater than 1 and less than 10. Then it's going to be multiplied, and we're going back to the old-fashioned multiplication sign. This is the only time that I really want you to use that instead of the dot. So do not use the dot. Go back to the x with scientific notation, and then we're going to do times 10 to the something power. That exponent is going to depend on how many times the decimal is actually moved. And so looking at our first example, again, we're going to have the format of this. And so if you'd like to draw your boxes to be able to help you remember your format, that's perfectly fine. Okay. Um, if you look here, there is no decimal, but we know that just because it's not written doesn't mean it doesn't exist. It's actually right here after that last 0. And we're going to move our decimal until we have one digit in the remaining decimals, or until the number that, by moving it, the number that's created is greater than 1 but less than 10. So we're going to move it once. Right now the number that's created is definitely greater than 10, so we've got to keep going. We'll go a third time, and if you look here, if the decimal were here, we would have 687.000. 687 is definitely bigger than one digit, and it's definitely bigger than 10, so we need to keep going. Go one more spot. Now we have 68.7. Again, we only want one digit here, or we want it to be less than 10, so we move it one more time, and now we have 6.87. Which would give us 6.87 that is bigger than 1. 6.87 is bigger than 1, less than 10. That's what we want. And so now we need to figure out how many times we move the decimal. We went once, 4, 5 times. So we'll put a positive 5 there. Because we moved the decimal to the left, the exponent is positive. The way I like to think of it is positive exponents should give big numbers. 687,000 is definitely a big number. This one is 50 million. Again, the decimal starts here. I'm going to put our boxes so that it kind of helps remind us that we have one digit, then the decimal, then the remaining digits, times 10 to the something power. So we're going to go over once, twice, 3 times, 4, 5, 6. Now if I stop right here, that would give me 50.0. That's still too big, so we need to go one more spot. And now it gives us 5.0, which is what we want. Another way to write that is just 5 times 10. And we're going to find what our exponent is here. But before we go on, I want to point out that if we were to move one too many spots, then that would give us a decimal here. It would be 0.5, which would then go 0.5, and there would be nothing, or a 0 would be in this box here. Remember, this has to be bigger than 1, but less than 10. And so this number 0.5 is definitely not bigger than 1. So we cannot do that. I'm going to take that away. Now, how many times do we move it? Once, twice, 3 times, 4, 5, 6, 7. And so either one of these answers is acceptable. You can either have 5.0 times 10 to the 7th or 5 times 10 to the 7th. Now let's try a number that's really, really small. These back here, really, really big numbers, they have positive exponents. One that's really, really small is typically going to have a negative exponent. So now we know where our decimal is, but remember we have to move it to where it's bigger than 1. If I start moving the decimals this way, it's just going to keep getting smaller and smaller and smaller. So be careful. Instead, we're going to move it this way, to the right, and if we left it right here, it would be 0.792. 0.792 is not bigger than 1, so we're not quite there yet. We've got to keep moving. We move it one more time. Now we would have 7.92. 7.92 is bigger than 1 and less than 10, so it goes right in here. And again, notice one digit went in here, the remaining digits went in this last box. We're good. So how many times do we move the decimal? 1, 2, 3 times. And remember, because it was a really, really small number, it's negative. Or any time we move the decimal to the right, it is negative. Let's look at another example here. Again, we're going to use our boxes. So we're going to have to move it again to the right. 3, 4, 5, 6, 7. And so now if I rewrite this number with the decimal place right here, we would have 35.76. But at this point, you should realize there's a problem. 35 is definitely bigger than 10. Or another way to look at it is 3 and 5. Remember, that would mean that they'd have to be in like this. That puts more than one digit in there, which is against what we want to do for scientific notation. So this tells me we went too far. Let's bring it back one. Now, if we bring the decimal straight up, 3.576, which is good. Notice how I write the remaining digits here. We moved it 1, 2, 3, 4, 5, 6 times. It is a negative exponent because we moved it to the right. So 3.576 times 10 to this negative 6th power is our answer. And now let's try to do the opposite. This is a number that is in scientific notation. Can we write it in standard form or decimal notation? 8.495. I'm just going to start with the number they gave us. We know that we have to move the decimal 5 times, but the question is, do we move it 5 times to the left or 5 times to the right? Well, if I were to move it 5 times to the left, I think you would agree that that would give us a really, really, really small number. It would give us 0.00008495. That's a small number. But if you notice, the exponent is positive, so it should be giving us a big number. So I'm going to go ahead and say that this is probably not the right answer. Well, let's try moving it to the right, see if we get a big number. 2, 3, 4, 5. Now you have 849,500, which is a big number. We were supposed to move it to the right, so this is our answer. I hope that helps you with your basic understanding of scientific notation. Tomorrow we'll start diving into how to do operations with numbers in scientific notation. Good luck.